hi students. Today we're doing an AB question about definite integrals, areas, and volumes, and we'll do it in 12 minutes or less. Let's show math who's boss. So, our first question is about area of a region. This is going to involve definite integrals. In particular, GRALS, there we go. In particular, we want an area bound between the x-axis, the graph of y equals the square root of x, and the vertical line x equals 4. Well, here's the x-axis, here's y equals the square root of x, roughly. And the vertical line x equals 4, we'll just put that right there. Now, an area is simply found by doing an integral. We're finding this area, and thankfully an integral gives you the area between a curve, in this case y equals the square root of x, and the x-axis, which is one of the boundaries we want anyway, so that makes this one pretty easy. And we want it between the values x equals 0 right here and x equals 4. So we just set up the integral from 0 to 4 of the square root of x dx. Don't forget to write dx. Don't want to lose a point for something dumb. Now this is a calculator problem, so we could just punch this in the calculator, but let's do it the hard way anyway. This is the same thing as saying x to the 1/2 power, and that's a much more calculus-friendly way of writing things, because now we can just do the reverse power rule. When we anti-differentiate, we raise the exponent by 1 and we divide by the new exponent. Dividing by 3/2 is like multiplying by 2/3, so we get 2/3 x to the 3/2 power, and then we just have to plug in our bounds, 4, 0, and subtract them. Well, we get 2/3 to the times 4 to the 3 over 2. Now 4 to the 3 over 2, that's the same thing as 4 to the 3rd power and then the square root of that, or the other way around, the square root of 4 cubed. Either way, you're going to get 8. So that's 2/3, and I'll just say square root of 64. You could also say cube of 2. So that's 2/3 times 8, which is 16 over 3. When we plug in 0, well, 0 to the anything is 0 times 0, so 16/3 minus 0, that's 16/3. Like I said, we could have done this in the calculator all along, so let's try that. We'll use it just to check our work. 0, 4, square root of x, dx, don't forget that part. And we get 5.3 repeating, which is the same thing as 16/3. Either one would be an okay answer. But it's good to see that we got the right thing. Alright, now down here, we want the value of h so that the vertical line x equals h divides the region, the one we just did, into two regions of equal area. Well, there's two ways of doing that, but either way, what we're doing is we're drawing a vertical line right here, and we want this area to equal this area. In other words, we want this blue area to be the same size as this orange area. Well, if we want this area to equal this area, then what we want is for this integral to equal this integral. From 0 to h, from here to here, from here to here, from h to 4. Again, there's another way of doing this, and we'll talk about that when we score this later. Well, we already know the integral because we already did it. That's just going to be x to the 3 over 2 times 2/3. And all we have to do is plug in 0 and h. Well, when we plug in h, we'll just get h to the 3/2, and we'll do 2 over 3 minus, well, 0 again. And over here, when we plug in 4, we already know what that is. It's 16 over 3. We just did it up here. And when we plug in h, well, we just did that. So that's even easier. 2h to the 3/2 over 3. Well, now it's just algebra. We got to solve for h. So let's move all our h's to one side. Of course, we can ignore the 0. What we're going to wind up with is 4h to the 3/2 over 3 equals 16 over 3. Well, it stands to reason if this over 3 equals that over 3, then this equals that. We can just kind of ignore the 3's, or if you prefer, multiply everything by 3 so it cancels out. We get 4h to the 3 halves equals 16, so h to the 3 halves equals 4. And to undo an exponent, you want to nest it and do the whole thing to the reciprocal exponent. So we're going to raise everything to the 2/3 power to cancel that out. 4 to the 2/3 power, that one I can't do in my head, so let's just use the calculator. When you have access to a calculator, yeah, use the calculator. So we get h equals 2.5, and let's round to 3 decimal places. That's a good rule of thumb. Even if the last decimal place is 0, include that. That still counts. It matters. Okay, now we're trying to find a volume. That's just an area also. I'm sorry, not an area. That's just an integral also. An integral is either an area or a volume. And it's the same r, and we're rotating it around the x-axis. Now volume, as you should know, is equal to the integral of area. So we just need a formula for area. Well, what we've got this time is we've still got this shape, but we're spinning it around the x-axis. So we get a shape that looks like, I don't know, a ham? Something like that. And if we were to take a slice through the paper, we have to picture this being spun around the axis into and out of the paper. If we took a slice straight through, we would get a cross section that looks like a circle, or it would kind of like a disc, like a coin. So those areas are areas of circles. That's the area, and the formula for the area of a circle is pi r squared dx. Don't forget the dx. Anyway, the radius of these circles happens to be the distance from the x-axis to y equals the square root of x. It just is the square root of x. So that's the integral from 0 to 4 of pi square root of x squared, which is a really simple integral. When you square a square root, they undo each other, they cancel out. Also, we can go ahead and kick this pi out here. Any constant inside an integral, you can just kick it outside, even if it's a negative number, which is really handy sometimes. So we've got something as simple as pi times the integral from 0 to 4 of x. That's a really simple integral. We just go ahead and increase the exponent by 1 to squared, divide by the new exponent, 2, and now we're going to plug in 0 and 4. Don't forget, of course, we're still multiplying the whole thing by pi. Well, when we plug in 4, we'll get 16 over 2 pi times 16 over 2, and when we plug in 0, we get 0. So that turns into just 8 pi in the end. And finally, we've got almost the same problem as part B on the last one. Vertical line x equals k, so we're doing kind of the same thing. We draw this line, x equals k. Don't forget, it's k, not h. If you write h, you might actually lose a point. Always use what they give you. We want this orange volume to be the same as this blue volume. Well, if we want this volume to be this volume, it stands to reason we want this integral from 0 to k pi of x dx to equal this integral from k to 4 pi outside x dx. Well, if pi times this equals pi times that, we can just kind of ignore the pi's. Or in other words, divide both sides by pi. We already know the integral because we already did it. So again, we get x squared over 2. Here we're going to plug in k and 0. When we plug in k, we just get k squared over 2. When we plug in 0, obviously we get 0. Over here, we're going to get the same thing. X squared over 2. It's just we plug in 4 and k. When we plug in 4, we know what we get. 16 over 2, we get 8. minus k squared over 2. Just like last time, we're going to gather all our k squareds, or just all our k terms together. K squared over 2 plus k squared over 2 is just going to be k squared equals 8. So k equals the square root of 8. If you wanted to, you could write that in decimal form. I'm just going to leave it like that though. Okay, so let's get out the grading rubric and see how we did. Oh, just over 10 minutes. So this first question, I thought it'd be worth 3 points. It turned out to only be worth 2. 1 point was worth just setting up this integral right here. I thought that would be worth 1 point, but then I thought using the reverse power rule might be worth another point, but nope, this is 1 point right here, and getting the correct answer as usual is worth 1 point. So we can give ourselves 2 out of 2 for this one. The second half is also worth only 2 points. Now we can do it this way, just like we did here, or it turns out you could also just set this integral, or this integral, either one, equal to 8/3, but because it stands to reason, if h divided it perfectly into half, then each half, keep in mind this is one half, this is the other, this represented orange, this represented blue, each half would have to be worth equal, each half, excuse me, would have to be equal to exactly half of the whole thing. This would be 8/3 and this would also be 8/3, so you could just make one of these and set it equal to 8/3. It actually makes the algebra easier later on. The integral is the same either way. So doing it this way, you could either set these two equal to each other, or you could set one of them equal to 8/3. Either one of those was worth 1 point, so we can give ourselves 1 point here, and getting the correct answer was 1 point also. It's worth noting that h equals 2.519 was also considered an acceptable answer. But yeah, you usually want to use 3 decimal places. That's a very good habit to get into. But either way, we can give ourselves 2 out of 2 this time. Now let's have a look at the back. Okay, volume questions. The first one was worth 3 points. One of them was set up the integral and get just the limits, that being these bounds. I like calling them bounds because the limit is just a little confusing. What do you mean, the limit as x approaches infinity? But anyway, getting the upper lower bounds or limits correct was that and the constant, and by constant it means pi. Getting those correct alone was worth 1 point. Getting the integrand or the inside of the integral was another point. So you got 2 points just for setting up the integral, and then 1 point for the correct answer. If you're ever in doubt and you know you want an amount of something, just set up an integral and there's a good chance you'll get 1 point for setting up an integral. So we get 3 out of 3 for that one. And this one is almost the exact same way. You get 1 point for setting these equal to each other, or just like last time, you could have set just one of them equal to 4 pi, because remember, these are each half of the entire thing. So if these two together are 8 pi and they're each exactly half, then each one is 4 pi. So you could set either one of these equal to 4 pi and solve for k that way, or you could set them equal to each other and solve for k. Either way, you should get the square root of 8. And just like last time, if you write that in decimal form, or if you had written 8 pi in decimal form, that'd be okay too. It's just when you do, always go to 3 places if possible. And of course, we could have busted out the calculator for either one of these too. We just decided not to, I guess. Of course, if we had busted out the calculator for this, we wouldn't have known what x squared over 2 is, and we would have had to do it anyway down here to be able to do the algebra. And remember, calculus is awesome.